Good afternoon, class. My name is Nathan Berger, and today I would like to present my final project for regarding the Bob White Manatee Project. So again, good afternoon. Today I'm presenting my story presentation format. As you can see, my ArcGIS Online account and project, Bob White Manatee Project. So let's get started. So the scope of this project for a GIS analyst determine whether or not laying this transmission line in Southwest Florida is feasible. Does it make sense? And how is it going to affect the local community in the two counties in which the line is going to be laid? But before we get into that, I'd like to first define, what a transmission line is. As an analyst, we kind of need to understand with this project, what are we doing for this engineering firm? Definition of transmission line, it's a specialized cable or structure designed to conduct electromagnetic waves in a contained manner. Depicted on the left over here is a steel pipe for a transmission line. A transmission line essentially is provide electricity to whether for commercial or residential use. And particular, we know a few parameters already, such as they are going to use steel insulation, and this transmission line is going to be laid between Manatee and Sarasota County, across the two counties in southwestern Florida. The objective is to provide the community electricity east of I-75, and we want possible. And we'll get into that more as the presentation goes on. The objective of this project is to consider best way of laying the line. As GIS analyst, I want to establish the most efficient way to solve this problem. So what are some parameters that need to be taken into account when installing this transmission line? Well, we need to look at a lot of different things, such as the land that we're going to take up to install the line, with construction, debris, the land usage. Also, we need to take into account the homes of people who already live in that area or who may own property, the effect on schools, the cost of the project, in any protected environmental areas that could be degraded or even devastated from laying this transmission line and installing it. So something to note too, the route was chosen after evaluating 1,275 alternatives using objective data and GIS analysis. So we already have a determined corridor in which we want to install this transmission line. I've also provided here some buttons. So if you click these links, it will give you some more information about historical court data regarding. So this link it's an article about radiation from power lines. So one thing I wanted to highlight here is one of the criteria for the transmission line too is the effect of radiation. I know some people have differing opinions on this, but essentially transmission lines do emit radiation. It is low level of radiation considered in this graph here with the power lines. But they are running studies to see the effect on adults and small children, especially in regards to leukemia cancer. So it's something we want to take into account when within the proximity of the transmission line, put it down where people are living, where kids are going to school, etc. So that's something I wanted to highlight here. Is it's something that might be overlooked, but considered when this transmission line is installed. Also, we keep talking about transmission lines and what they do, wire electricity. For the scope of this project, we definitely know that we're putting in a 230 kilovolt transmission line. It's a high voltage power line. And kilovolt stands for unit of potential energy. So it tells you how many volts are in the line itself. So that's going to be important because that determines the cost of the transmission line because of the cable and the steel piping that's provided. It kind of gives us an idea of what to expect for policymakers, how much this line will cost. So again, criteria for this project, we need to know how close homes are in regards to the transmission line, how close the schools are and daycares, the damage to environmental lands, such as protected lands for conservation lands for wildlife or state parks, also the damage to wetlands and uplands in the vicinity of the transmission line. And we want to know the length of the transmission line with a few extra parameters, again, such as the voltage I just said earlier, the 230 kilovolts. That's going to help us determine the cost of this project. So policymakers can understand it's not just all these risk factors to the community, but also how much money is going into this to make it feasible. So depicted here is a final model that I put together. So it defines what I stated earlier, our problem statement. We need a transmission line that needs to be installed east of I-75 for the encompassing an area of these two counties to provide electricity. We have our criteria I just stated above, homes, schools, daycares, in proximity to this transmission line, damage to the community, environmental lands, etc. I list the different maps, deliverables that we're going to provide to help answer some of these questions, as well as the data involved. We're going to be using aerial imagery. We're going to use point layers, polygon layers, feature classes, shape files, tables, etc. And ideally, our final calculation here should answer these questions to our main criteria. How is it going to affect the homes, the schools, the wetlands, the uplands? What is the length of this transmission line? We're going to answer all these questions. So for criteria 1, as you can see, I have a map depicted here. And I have a little written summary here kind of outlining what we're doing for this. So what I started doing is I took all of the imagery required for the project that was collected from Lavin, and I had to define the projection for a coordinate system for each imagery file. That way, when you start doing measurements and analysis, all of your mensuration is going to be accurate to your local projected coordinate system that you have for your map. So I actually built a little model to do that. And once I had projected all of my imagery, I went ahead and pulled in my roads, my study area, some county boundaries, the preferred corridor depicted in yellow, which is where the transmission line is assessed to be installed. I clipped out the roads. I clipped all the data out except for the county boundaries to fall within the study area, this red polygon here. Then at that point, I did a 400-foot buffer extending out past the preferred corridor. And then I looked at imagery and digitized homes that fell either within this 400-foot buffer or within the preferred corridor. So that tells me these are the homes that will be affected by this transmission line. They're within proximity. So after looking at imagery and Google Earth, I was able to digitize approximately 53 homes. In doing so, I also clipped out all of the land parcels that fell within the 400-foot buffer and the preferred corridor, which I ended up with 255 land parcels. So what does that mean? That means 53 homes and 255 land parcels or land areas that are owned by landowners will be affected by this transmission line. And again, I digitized these homes. I did a point layer using aerial imagery that was defined projected. As you can see, the homes in red are the homes that fall within the actual corridor that will be affected the most. And then the homes that don't necessarily fall within the corridor, but they do fall within that 400-foot proximity of the corridor that will also be affected, depicted in orange. So this would be our final answer for that. For criteria 2, we had to go FGDL for all of these schools and daycares located within the proximity of our transmission line. So I collected all of the schools and daycares as point layers from FGDL, and I clipped out their locations for the Manatee and Sarasota counties. And then I clipped them again to show only what is actually within our study area. By doing the red stars here, I have my daycare facilities, and the blue icon, I have my schools. Just by visually looking at this map, I know that they don't fall anywhere near my preferred corridor or within the 400-foot buffer proximity. So I can assess that there are 0 schools or daycares that will be affected by the transmission line, which is awesome. I did note the closest daycare facility, which is the Harvest United Methodist Church, and the closest school, Robert Willis Elementary School, with their coordinate locations. But as you can see, one of them is over 1,000 meters away. The other one, the church, is over 600 meters away from the preferred corridor. So they're nowhere within proximity, which is good. So at least we don't have to worry about that from the scope of this project. And again, I clipped out, after collecting the data, I geocoded the points to show up on the map. I added them in. I verified that they were projected to the same coordinate system. I clipped all of the points out to be within my study area. And then I also ran an intersect tool to see if any schools or daycares fell within the preferred corridor boundary. And I got a 0 return, which means that none of them do, just to verify these results. Okay, so we've looked at homes and property owners. We've looked at schools and daycares to make sure that kids and the citizens that work at these facilities are going to be safe. Now we can start looking at land. So environmentally sensitive lands imposed by the transmission line. As you can see here, depicted in green are the uplands, blue are the wetlands, and burgundy are the conservation lands. So what you are seeing is all of the lands that will be a transmission line project. So what I did is I outlined my preferred corridor. I got the land data from the NWI study area, and I also got the conservation lands for Manatee County and Sarasota County. So I clipped these layers to only show what is actually within the study area, and then I did my I did a 400-foot buffer again outside the preferred corridor, and I did an overlay layers tool, which then intersected all of the polygon land that fell within the proximity of the corridor. So by doing so, all the land that you see highlighted depicted within those yellow boundaries is land that will be affected. So as my results, after doing the overlay and intersect for the conservation lands and for the wetlands and uplands, I categorized the NWIC code. Everything that was a U was an upland. Everything that wasn't a U was a wetland. And these lands consist of forest, deciduous, evergreen, riverways, waterways, etc. So our total percentages here at the bottom. So total conservation land is the total conservation land for Sarasota and Manatee County. The total wetlands and uplands, total land acreage, consists of all of the land within the study area red polygon. So then I took the acreage of what I had calculated with my analysis for my overlay tools, and I took this number and I divided it by their totals, and that allowed me a percentage of what land is actually being affected by this project. And so far, it's actually pretty good. So the total affected wetlands and uplands was a 6.59%. So basically over 1,000 acres and about 77 100 acres of wetlands and uplands are being affected by this project. That seems like a lot of acreage, but when you look at the percentages of the total, it's actually very low. Conservation lands are protected lands for wildlife, state parks, and the environment. Only 366 acres actually fall within 400 feet proximity of the preferred corridor, which is 0.23% of total conservation lands for Manatee and Sarasota County. So that's really good. And to calculate the acreage, I had to make sure everything was projected to the Albers coordinate system. I added a field to each data set called acres or num acres. And then I calculated the geometry of acreage by area. And then I did a statistics histogram to get the sum of total acreage per data set. And then again, I divided it by these totals here, which is the total conservation land for Manatee and Sarasota County, and then the total lands, wetlands and uplands of just the NWI study area, which is within this study area red polygon. So the fourth criteria, this one was very straightforward. We drew our preferred corridor. We have our path for our transmission line. I ran a polygon to where it selected this polygon, and I said I wanted to do a center line running from the start to finish to calculate the total length of the line, and I wanted it in miles. After running the tool, I got a data set of 3 rows, which are 3 combined polylines essentially to form one polyline, which equated to 25.4 miles. Right here, I wanted to show this formula. So we know the cost of the transmission line, because it's a 230 kilovolt line, the average, according to industry standards, is going to cost $1,100,000 times by the mileage, 25.4 that we just derived from this polygon to centerline tool. And then we have our 1.5 for our urban factor, because the transmission line is flat land and we're covering urban terrain, with a line length factor of 2 exceeding 20 miles to get our cost of transmission line. So the actual total cost is $83,820,000. The policymakers now can understand the scope of the expense of this project, and the engineering firm understands what they need to put in to make this happen. So this is a quick capture of final results for the Bob White Manatee project. We have total homes affected 53, number of parcels being affected 255, number of schools and daycares 0, percentage of wetlands, percentage of uplands from the totals of the study area 95.95% and 5.64%, and then the percentage of environmentally protected conservation lands from the total of Manatee and Sarasota County being 20.23%. And then we also have the length of the transmission line, 25.4 miles, and the overall cost of the transmission line, which is $83,820,000. So what is the so what factor here? The overall conclusion is that this is a considerable course of action. This transmission line can cause radiation to cause, leukemia and other health issues from the electric fields that are caused from the frequencies of these power lines. But fortunately, again, for this project, there are no schools or daycares located within proximity of the transmission line. We only have 53 homes being affected, with 255 land parcels, and a lot of that is farmland. We have low percentages of total land being affected in regards to wetlands and uplands. As far as conservation lands go, only 366 acres. It's extremely low compared to the total available to both counties. So I would assess that this project should have a low risk to the environment, low risk to population, to citizens, the community, and it's going to try to preserve as much protected environmental land as possible. Again, if you want to take a look, I have a web map here displayed. It's got all of the data mapped in here. You can analyze, click around, query data. It's going to have everything in here for my project. I also have a link to my web map on ArcGIS Online, my blog post on portfolio site on blogger.com, and I'll be uploading this recorded video here to the presentation. Below, I have my sources down here, and if you have any questions, feel free to reach out to me via email or go to my blog site. You can comment or my presentation. Thank you so much, and this concludes my final project.